Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. This week in astronomy, dark matter, biggest black hole merger in hidden galaxies. Dark dwarfs, a new clue to what dark matter is. Dark matter is something scientists know is real, but they still don't know exactly what it is. It doesn't glow, reflect light, or interact with normal matter in any obvious way. But they know it's there because it holds galaxies together with its gravity, otherwise, galaxies would fall apart. Scientists think dark matter might only interact with itself, not with regular matter like us. If that's true, dark matter particles could crash into each other and destroy themselves. This destruction would release energy. But for that to happen, dark matter has to be packed tightly in one place. A new idea from researchers suggests that this might happen inside a special kind of object called a brown dwarf. Brown dwarfs are bigger than planets but not big enough to shine like stars. When they form, they start like stars, but they don't get enough gas to begin the nuclear reactions that power real stars. So, they stay dim and cool for the rest of their lives. Because brown dwarfs are so faint and small, they are hard to find. But if dark matter is inside them and starts to destroy itself, that process could release energy and heat the brown dwarf up. That extra heat could make them easier to detect. So, instead of just brown dwarfs, we might be able to find dark dwarfs, brown dwarfs powered by dark matter. This idea was explored by a group of scientists led by Juna Kroon, who works at Durham University. Her team believes these dark dwarfs might exist near the center of our galaxy. That's because there's more dark matter in that area, making it more likely that brown dwarfs there could gather enough dark matter to start the self-destruction process. The key to spotting these dark dwarfs might be a form of lithium, called lithium-7. Normal brown dwarfs use up their lithium-7 early in life, but dark dwarfs wouldn't burn theirs because the energy would be coming from dark matter, not fusion. So, if astronomers find a star-like object with lots of lithium but more mass than a normal brown dwarf, it could be a sign that it's a dark dwarf. These dark dwarfs would be a little heavier than brown dwarfs and would stay the same brightness and temperature over time. They would also keep their lithium, while regular brown dwarfs would lose it. That makes lithium a kind of marker scientists can use to tell the difference. Detecting dark dwarfs would be a big deal. It would help scientists figure out what dark matter is made of. One strong possibility is something called WIMPs, short for weakly interacting massive particles. This theory only works if dark matter is made of these WIMPs or something very similar that can destroy itself and release energy. Finding dark dwarfs wouldn't prove dark matter is WIMPs for sure, but it would be a strong clue. And even if WIMPs aren't the answer, discovering dark dwarfs would show that dark matter is made of something heavy that interacts with itself in a special way, something we haven't seen before. Even though these dark dwarfs are very cold and hard to find, scientists think telescopes like the James Webb Space Telescope might be able to see them. Or, they could study lots of star-like objects and look for patterns that suggest a group of them might be dark dwarfs. If even one dark dwarf is found, it would bring us much closer to understanding dark matter, one of the biggest mysteries in science today. Biggest black hole merger ever detected. Scientists working with the LIGO, Virgo, and Kagra observatories recently made a major discovery. They found the biggest black hole merger ever seen through gravitational waves. This happened on November 23, 2023. And the new black hole that formed from the event is about 225 times heavier than our Sun. The signal from this event was given the name GW231123. LIGO, which stands for Laser Interferometer Gravitational Wave Observatory, first made headlines in 2015 when it detected gravitational waves for the very first time. Gravitational waves are tiny ripples in the fabric of space and time caused by powerful cosmic events, like two black holes crashing into each other. That first detection came from a merger that created a black hole about 62 times the Sun's mass. Since then, LIGO joined forces with two other detectors, Virgo in Italy and Kagra in Japan. Together, they form a global team known as the LVK collaboration. Over the years, they've detected around 300 black hole mergers, including more than 200 just in their latest round of observations. Before this latest event, the biggest black hole formed through a merger was seen in 2021 and was about 140 times the mass of the Sun. But this new discovery is even more massive. It was created when two very large black holes, one around 100 times the Sun's mass and the other about 140 times, merged into one. Besides being extremely heavy, these black holes are also spinning very fast. In fact, they might be spinning as fast as the laws of physics allow, based on Einstein's theory of general relativity. That makes this event especially hard to study, because the faster the black holes spin, the more complex their behavior becomes. Scientists had to use advanced computer models to try to understand what happened. This discovery is important because, according to current theories, black holes this large shouldn't be able to form in the usual way from dying stars. Some scientists think these two black holes might have already formed from earlier black hole mergers. That means we might be seeing black holes made from a chain of mergers over time. This kind of observation is helping researchers learn more about how black holes form and behave. It's also pushing the limits of what current technology and scientific models can handle. Experts believe it will take years to fully understand all the details of this particular event. It's possible that the data from this detection could even reveal new ideas about black holes that scientists haven't considered yet. The LIGO, Virgo, and Kagra detectors are tools that measure incredibly tiny changes in space caused by events like this. They started their fourth round of observations in May 2023 and are still gathering more data. Results from the first part of this observation period are expected to be shared later in the year. The new black hole merger, GW231123, will be discussed at a major science conference happening in July 2025 in Glasgow, Scotland. The data from this event will also be made public so other scientists around the world can study it too. This discovery is not just about one big black hole, it's about opening a window into the hidden parts of the universe and learning how much more is out there waiting to be understood. Hidden galaxies may be orbiting the Milky Way. Scientists at Durham University believe there are many more tiny galaxies orbiting the Milky Way than we've seen so far. They used supercomputers and advanced math to look deeper into this mystery. Their research suggests there could be 80 to 100 extra satellite galaxies around our own, much more than the 60 we already know about. These galaxies are incredibly faint and difficult to see. Some of them are so stripped of their material, especially the dark matter that usually surrounds galaxies, that they've become almost invisible. Because of that, they don't show up in most computer simulations. That's why the researchers call them orphan galaxies. They've lost the big dark matter halos they were born in, possibly pulled apart by the Milky Way's own gravity over billions of years. But the scientists think these orphans are still out there in real life, just hidden from our view. Their work supports a major theory about how the universe works, called the Lambda-Cold Dark Matter Model, or LCDM. This model says most of the universe is made up of things we can't see, only about 5% is made of atoms like the ones that make up people, planets, and stars. About 25% is dark matter, which we can't see but know is there because of how it pulls on things. And the rest, about 70%, is something even more mysterious called dark energy. According to this theory, galaxies like ours form inside huge clumps of dark matter, and most galaxies are small and orbit around bigger ones like the Milky Way. For a long time, scientists have noticed something odd. According to LCDM, there should be way more of these small satellite galaxies than we've actually seen. That mismatch has been a problem for the theory. But the new study shows that we may have been missing the faintest and smallest ones, simply because they're hard to detect with today's technology. They've been around for billions of years but are so dim they've slipped past our instruments. The Durham researchers used some of the best tools available to study this. One is a powerful computer simulation called Aquarius, which shows what dark matter around the Milky Way might look like in high detail. The other is a tool called Galform, developed at Durham, which follows how galaxies form and change over time. By combining the two, they could better understand where these faint galaxies might be hiding. Their work shows that many small galaxies likely got pulled close to the Milky Way long ago. Over time, gravity stripped away their dark matter and stars, leaving behind these ghost-like galaxies. But they're still there, and if we build better telescopes or use smarter methods to look, we might finally spot them. Some of these predicted galaxies may already have been seen. In recent years, astronomers have found about 30 tiny objects that might be satellite galaxies, but it's not clear what they are. They could be dwarf galaxies with some dark matter left, or just dense star clusters. The researchers think these new objects might be part of the missing group they predicted. This study is exciting because it might help solve a long-standing puzzle in our understanding of the universe. If telescopes like the Rubin Observatory, which recently started operating, find these hidden galaxies, it would be a big win for the LCDM theory. It would show that with the right combination of physics, math, and computing power, we can make bold predictions about things we can't even see yet, and then go out and find them.